as a weaker attack does, or if those sets are completely different. We present Bluff, an interactive visualization tool for discovering and interpreting how adversarial attacks mislead DNN into making incorrect predictions. Our main idea is to visualize activation pathways within a DNN traversed by the signals of input data. For given input data, an activation pathways consist of neurons that are highly activated and the most influential paths. Activation pathways represent what features are detected and how those features are related to contribute to the final prediction. To understand how the attacks manipulate the neurons and the paths inside the models, Bluff visualizes the activation pathways of both benign inputs and attacked inputs. That is, Bluff finds and visualizes the most activated pathways given benign and attacked input data. Bluff also visualizes the most inhibited paths by the attack to uncover where the attack is blocking the signals to the benign path. Also, Bluff visualizes the most excited paths by the attack to uncover where the attack stimulates to induce the activation pathways going towards wrong directions. The Bluff interface tightly integrates three coordinate views. It consists of control sidebar, graph summary view, and detail view. Here, a user inspects why a deep learning model misclassifies adversarial giant panda images crafted by the projected gradient descent attack as armadillo. In the main graph summary view, we visualize the activation pathways of benign and attacked input data. Here, each vertex represents a neuron. When hovering over a neuron, Bluff shows the detailed information of the neuron. The detailed view for a neuron shows a feature visualization and example data that visualize what feature the neuron is detecting. For example, for giant panda images, this neuron looks for face of animals that have white furs and dark eyes. Feature visualization is a synthesized image that maximizes the corresponding neuron's activation. Dataset examples are patches of images from the training data that highly activate the corresponding neurons. We also show how the neuron's median activation will change according to different attack strengths. Here in the graph summary view, the neurons are represented with different colors based on their roles. The green nodes are the most important neurons only for the original class, giant panda, which means they are highly activated by benign giant panda images. The blue nodes are important neurons only for the target class, armadillo. The orange nodes are the most important neurons for both original and target classes, giant panda and armadillo. The red nodes are the neurons that are highly activated by only successfully attacked images. These neurons are exploited by the attack to induce the incorrect prediction. By exploring the activation pathways, PGD successfully perturbed pixels to induce the brown bird features, an appearance more likely shared by an armadillo than a panda. Both armadillo and brown birds have small, roundish, and brown bodies. The brown bird neuron then contributes to the armadillo misclassification by activating more features such as scales, bumps, and mesh. By using the options in the control sidebar, users can interactively filter the neurons and connections to visualize. For example, they can select to visualize all graph, or only highlighted neurons, or only pinned neurons. By using the highlight pathways options, users can select which activation pathways to visualize, such as most activated or most inhibited, excited, or most changed by the attack. By using the comparison mode, users can compare how attacks of different strengths have different activation pathways. In summary, we developed Bluff, an interactive system to understand how adversarial perturbations flow of the deep learning model. BLOB visualizes most activated, inhibited, excited activation pathways after the attacks, and provides flexible comparison of attack escalation. Thank you all for listening. I'm happy to take any questions.
We present columnar data augmentation through visual analytics. Kava lets users augment their data with additional attributes found on knowledge graphs. To construct a new attribute, each row of a dataset is mapped to a node on a knowledge graph. Each augmented datum is the result of a query over the knowledge graph in the neighborhood of that node.
The mixture graph is a data structure for compressing, rendering, and querying segmented volumes. Biomedical segmentations have evolved from mere annotations to first-class modalities. The mixture graph stores the computations required to render such nominal data directly on the GPU, including pre-filtering and lighting. Segment distributions can be queried efficiently using regions of interest.
Visualizations are about visual patterns. But there's more, much more. We show the connections between more than 100 arguments on why visualization works. And don't forget to check out our website.
TaxIMIS is an interactive visual analytic system to help tax officers identify suspicious tax evasion groups. The system integrates the traditional data mining algorithm and visual analytics techniques. 4 coordinate views are provided to support interactive exploration of tax evasion evidence. We demonstrate its usefulness through case studies using real-world test data and expert interviews.
Traditional clustering tools do not include users in the analysis loop. We present PK clustering, a new approach for interactive clustering using VIS. First, users specify their prior knowledge. Several algorithms are run and matched with the prior knowledge. Users then build a consolidated clustering iteratively with suggestions based on consensus, the graph, and their knowledge of the data. The result is a consolidated clustering.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. With Tableau, you can keep on asking questions in the data until you discover the root cause. Share your analysis securely. Your entire organization can access these interactive dashboards from any browser or mobile device to find their own answers. Tableau. Answer questions at the speed of thought.
Hey everyone, I'm Junhan Zhao, a PhD candidate at Purdue University, computer graphics major, and a research internship at Bosch Research North America. Here, we are presenting our recent research, Persevere, using factorized prototypes to visually interpret and diagnose deep neural network. This work is co-authored by research scientists at Bosch, Zhen Dai, Dr. Panpan Xu, and Dr. Liu Ren.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. With Tableau, you can keep on asking questions in the data until you discover the root cause. Share your analysis securely. Your entire organization can access these interactive dashboards from any browser or mobile device to find their own answers. Tableau. Answer questions at the speed of thought.
Hey, welcome everybody to our application spotlight on recent challenges in medical visualization. This is a joint effort of myself, Noeska Smit from University of Bergen, and Thomas Wischgoll from Wright State University. We thought first explaining on how and why do we have this specific spotlight. So we watched into the publication numbers of medical visualization papers, and we figured that the number of publications on TVCG on medical visualization is actually decreasing. So I brought this little plot here where you see that the numbers are decreasing, and we're actually wondering why, because there are so many open problems in medical visualization that people can target. And there are so many new research directions in medical visualization that we really wonder, why isn't it worth publishing that? medical images are still one of the most prominent examples for novel visualization approaches, especially in scientific computing or in scientific visualization. Every time you're bringing up a new technique, you probably use a medical data set to show the effectiveness of your technique, because medical data sets are very unique and very interesting, and they're real world data sets with having all those issues that real world data sets can have. So we figure that we are still into the point where we have so many open problems in medical visualization and so many new flavors that are coming up that where people can actually contribute from. So one of the things, or the left side is showing a list of what we think are open problems in medical visualization. And one is uncertainty visualization. So uncertainty is a big problem in medical visualization because you have all those captured voxels or images and you never know if you really see what you see there. There's multimodal visualization, which becomes bigger and bigger because clinicians are taking more and more images to figure out what's actually going in the patient. We also have to figure the problem of teaching of medical students where they should actually learn novel visualization techniques. We have surgery guidance where visualization can actually help really understanding what to do during a surgery and how to do the surgery. And we also figured like a big open problem is legal restrictions. Whenever you figure a new technique for medical visualization, you have to go through this very, very long and complicated process of bringing this into real applications and into a real product. On the right side, you see something that we figured as new flavors that actually became pretty recent, and let's say the last 5 years. We think there is a missing link to visual analytics in healthcare. So there was this workshop there has been some years ago, this workshop on visual analytics in healthcare. And we actually think there is a massive link on medical visualization, and we should create this link. There's also the missing link to biological visualization. You have all those nice visualizations and all those attempts to figure out what's going on in the RNA, DNA, and all those things that are going on in biology. And they're massively linked to medical visualization. So can we just create a link between those two worlds because they can really benefit from each other? There's also machine learning, which is probably not restricted to the medical application. This is a general thing that's coming up in VIS right now, but medical problems have turned out to be one of the counterexamples for machine learning in the past years. So this is absolutely a new flavor that comes into into medical visualization approaches. And there's also high performance computing coming up where you now have the power to examine multiple data sets of multiple patients at the same time and figure out how they interlinked it into each other, or if there are correlations that you can put all over a specific data set. So this is why we thought we need a spotlight about that. And to achieve this, or to make this spotlight, we got really 3 exciting talks. The first one's given by Anna Vilanova, and she's going to talk about visualization for AI in health. The second one's given by Bernhard Preim for recent developments in VR. And the third one is going to give by Eduard Gröller, which is Medicinae, Notitia, Visibilis, Vadis. And after that, so I want to ask you to keep you can put the questions on Discord and YouTube, but we will not answer, or the speakers will not answer the questions directly after their talks. We want to have a big panel discussion in the end. We really want to hear all the voices from the VIS community, how they feel about medical visualization, what needs to be done, what are still open problems, what can we change to make medical visualization more popular, to bring it back to that state where we actually have been and where we actually can solve problems that we figured in that area. So with that being said, I want to ask Anna Vilanova to start with her talk.
Okay. Thank you very much, Christina, for and all the organizers of this spotlight, and for inviting me to give my view on what are recent challenges in medical visualization. I agree with the organizers that there are a lot of challenges there. And well, I will give a bit of a view on what is a part of the challenges that I see. So as in a lot of disciplines, and health is not an exception there. So we are in the era where we can collect a tremendous amount of data. And from this data, the idea is that we will be able to make sense of it and to be able to make new discoveries by analyzing and getting insight in this data. Nowadays in health, you can acquire data of all types through sensors, through following people with iPhones and DNA and so on. And it's a big challenge actually to be able to understand this data. Of course, visualization can have a big contribution there. However, also a way to get use of all this richness of data is by machine learning. So machine learning has benefited a lot by the fact that all this data is available and it can be used. And health is not an exception in the use of machine learning and AI techniques. So this was done already for a long time in health and in medical image analysis. A lot of the problems were related to actually the use of machine learning. But with the advent of deep learning, this has been taken over completely, and it has been moved from a more model-driven kind of approach to a fully data-driven approach. And in all typical problems from medical image analysis, like segmentation of structures in images or classification and prediction, even for registration, deep learning is performing much better than classical techniques that were there before with more model-driven approaches. Furthermore, other methods have also been used, like, for example, using machine learning for the generation of modalities. So without doing the acquisition, being able to actually generate other modalities, or even using data-driven building of images by the signal that is obtained in the acquisition. In this way, you can obtain better and more qualified or images of higher quality. However, still, the success of these techniques have a difficult adoption in practice, actually. For some problems like segmentation is not really the case. I think adoption of this is quite well, but for others, it's still difficult to get them adopted in practice. And well, the thing, or one of the problems is that basically machine learning is often used as a black box, also when the methods were done in a traditional way. So basically what I mean by that is that if you have an image, you put it in, and then you get out, for example, in this case, simple case of cats and dogs, it tells you, okay, you put the image and it tells you whether it's a cat or a dog. So in this case, it says it's a cat. And if we would use a traditional way, still model-based, the features were done manually, and you can do some reasoning, maybe limited on what happened, why I'm getting the wrong result. But nowadays, with deep learning methods, this gets even more complicated, because actually everything is data-driven, even not the features are being built in a way that knowledge is used or they are designed. So you are interested in knowing why, if you want to then be able to make that this the right solution is given, like this is a dog. And if we are talking about cats and dogs, this is not maybe so important, because if you are happy with knowing that 90% of the times you will get the right result, and this doesn't matter. But if we go to health, and for example, you have a very well functioning machine learning method that tells you whether tumors are benign or malign, it's still difficult to accept that the doctor will tell you, well, I will remove half of your lung because you have there is a machine learning method that tells me that you have a malignant tumor, but is not able to explain you why is the case, or he doesn't even understand himself why this is the case and why this is needed. So yeah, so interpretation and understanding what is going on in the machine learning is important in health, and visual analytics can contribute to that, and visualization can contribute to that. I see three main aspects in which this plays a role. So one is diagnosis. What I mean by diagnosis, what I just explained, is whether you are able to define when a model performs well, when it doesn't, and whether you can detect in which situations it will be a problem. This is even a legal issue because the European Union has set a directive, actually, and I think this is also in other places in the world, where you have the right of explanation of a decision made by automated or artificial intelligence algorithm system. So actually you have the right to ask for an explanation when such a decision is taken. But you can go further with that. So actually, nowadays, the machine learning methods perform better than humans in some prediction types, for example. So then being able to understand what the machine learning method is learning can help to actually generate new knowledge. So not just the fact that you obtain better results, but that you can generate new knowledge by that. And furthermore, also in an example I showed before, also is the case, if you want to improve your model, you need to understand what the model is doing to be able to generate a better model. So as I said, visual analytics and visualization can help in all this and answering multiple questions that are related to these models in the clinic. And also one important factor when we talk about deep learning is the training data. Understanding the training data is very important. In medicine, data is very precious, and actually being able to build the data is very tedious and difficult. And actually making a good use of it and making sure that these models are not biased towards the kind of data you are using is also a very important factor. So yeah, so I'm not saying something really new here. So there is also already recently a lot of attention, not just in medicine, but in all kinds of applications in how to do this explanation of AI systems, CHI, or machine learning, basically, systems. And there are different methods that have been proposed for that, and there are systems that are a combination of these basic methods, but all still have problems and handicaps on them. So there are methods in which you are able, for example, if you have an image on an instance, you are able to have activation maps or maps that tell you what the machine learning has been looking at to make the decision. But often this is not really enough. Imagine if you are deciding whether a tumor is benign or malign, and it tells you, okay, the system has been looking at the tumor to decide that. It's not giving you very much extra information on actually what is looking at exactly to make the decision, right? If we look at the generation of explanations for the overall system, for example, to understand the different layers in a deep learning method, there are generative methods in which you basically try to generate images that produce these activations on the layers, and you try to interpret them. So these are popular methods that are used in machine learning. But actually, if you look at these images, when they are from natural images, sometimes, so often you can make something out of this, like it's detecting legs or ears of a dog or so. But it's not always the case. For example, in the image I'm showing, it's based on image, but what does this represent? Are these penguins or dogs, or it's a bit difficult to say. And if you go to something more abstract, like the images that come from scans, this becomes even more difficult to do. Like in the right, these are examples of trying to understand what layers are doing in a classification of a mammography, and it's very difficult to say what exactly this is being detecting. There are also other methods that use more semantics. For example, methods in which try to map the input and try to understand how this input is distributed in the Latin space, or and you use the semantics of the input that you can understand to be able to understand what is the structure at the end. So if we look at these images on the right, so when we have images of dogs and cats again, this is quite clear. You can distinguish quite easily what are the groupings, which kind of information is there in the grouping. But again, if we talk about tumors, this becomes much more difficult to do by just looking at the images, be able to identify this. So these methods are not so easy to translate to the medical domain, and all of them will have also their own peculiarities and would need different approaches for that. So a part of what I described, that the new methods have to be defined, I think there are a lot of challenges here in this direction. So one of the things is, I think in general, this is a problem that is not so well defined. So what is a good explanation? And often it's also said that you want to generate trust. So what does it mean exactly to generate trust, right? So this is rather vague definition. And also, if we look at this directive for the GDPR, it says you have to write off an explanation. I mean, you can get an explanation of how a system works, that it uses backpropagation or gradient descent also. And that's also an explanation. But well, this explanation probably is not very useful to a medical doctor. And so actually those explanations that are being done by ML and especially designers probably are not very effective for a medical doctor or patient or the user. So the communication between all these different components is very important. I also think to advance in this research field, the multidisciplinary is very important, because to advance there, you really have multiple disciplines that have to play a role there, and that all of them are heavy and important, right? So if you really want to understand what the deep learning is doing, you have to really understand how it works and how the different elements are there. Visualization, of course, but also from the more soft sciences. So if we want to explain something, and what is a good explanation, there are things that come from psychology and pedagogy, or how you put educational sciences, how do you set a good explanation. And finally, evaluation. I always think that medical visualization evaluation is a difficult issue in general, because you deal with it's dealing with experts, and it's often a few users are there. So how do you measure success is also not so clear, right? So how do you measure a good explanation? How do you measure that trust has been achieved? And how can you do that in a robust way is also a challenge. And with that, this would be the end of my presentation.
So do I... All right, thank you, Anna, very much for this very nice talk. Our next speaker is going to be Bernhard Preim.
Yes. Yeah. Thanks a lot for the kind introduction, for the organization of this application Spotlight. I thought a bit about combinations of medical visualization and virtual reality. We have a lot of fun in our group exploring this, but I think for the whole community, there are many interesting issues. What you see here in this introductory example is an immersive VR solution for exploration of blood flow data. Why virtual reality in medicine could be useful? I think that this immersion enables a good understanding of complex spatial relations as we have them in some parts of the human anatomy, for example, in the inner ear, or also in this neck area where we have a high density of intertwined structures. In the introductory slide, Christina said that medical education is important. I agree. And I would add that virtual reality can improve engaging and motivating experiences that are very useful for education. It's not quite clear yet whether this motivation lasts for a long time. That needs more investigation. But at least initially, it really has a strong effect. Surgical training, of course, can benefit from VR because with good virtual reality solutions, people are really immersed. And that means if they hurt a patient in VR and the patient is bleeding, they would take this seriously as in a real operation and not just as a computer game where it basically does not matter. There is also a lot of medical team training that can benefit from VR solutions. So here is just one example for teams that have to work together. And one thing that really works quite well already is exposure therapy. That is the treatment of anxiety such as fear of height or fear of speaking publicly or fear of flying. Where the immersive situation really makes persons believe to a strong extent that they perceive the stimulus really. So therefore, this works as an exposure therapy and people can be treated with this. Yeah, if you are interested in VR for medicine, it makes sense to look even in some quite old publications. There is a conference series, Medicine Meets Virtual Reality, that started in 1995 already. There are visionary papers primarily from Richard Zatava, so I mentioned two here. He himself was primarily active in surgery simulation, but he envisioned a number of applications for VR in medicine, including, for example, operating room design, which is quite complex, involves many constraints, and that can be improved by VR. What works quite well already is VR for rehabilitation, and that started also in the mid-1990s with work from Larry Hodge, Skip Rizzo, and Rothbaum. To look just briefly in one of these visionary papers from Zatava, so here are the major applications that he envisioned. Telepresence surgery, so here he thought about military applications, of course. There is a soldier in a battlefield that needs to be operated from remotely, and how this could be supported with VR solutions. I just mentioned this one word here, rehabilitation, but that is a broad term, that involves motor rehabilitation, cognitive rehabilitation, and both of them have a number of specific training tasks that can be supported with VR, and there are already good, even commercial solutions already. Yeah, with this slide, I briefly want to summarize what I think are major developments in the VR community. That is a mature community, meanwhile. So they think about avatar design for every cooperative solution. Different persons need to be aware of each other, of their position and intent, and therefore avatars are quite important. People walk around in an operating room, for example, so therefore locomotion techniques are needed. Walking would be the most natural one, but the tracking space often is limited, so you need other things such as redirected walking, and then you have to think about detection thresholds when people notify that somehow they get redirected, or teleportation. There is a lot of research on VR sickness and how to reduce the probability that this occurs, and the locomotion techniques are important for this. You need different selection and manipulation techniques in immersive VR compared to a desktop situation. For example, for selection, you often just grab things with your hands, what you would not do in a desktop situation. Also, system control is quite important. Visualization solutions often have a number of options that are available via a pull-down menu or a context-dependent pop-up menu. These are interaction techniques that would not work in VR, so you need different possibilities for this. And one thing that I really found interesting is the VR community has very strong evaluation methods. So they really have questionnaires for all aspects of the decisions that are taken in the VR system. So you can build on this. Yeah, so not only that, there is a lot of documented work available in the form of papers, but mostly these things are available in game engines such as Unity. I looked also a little bit at applied research in other areas, not only in medicine, because I found this a bit inspiring and there are parallels to medicine. Yeah. In medicine, we have, for example, the design of medical devices such as complex implants. Yeah, that may benefit from similar developments like VR for car design and manufacturing. Medical training somehow has similar goals like training in industrial settings, primarily increasing safety for both the surgeons and other physicians, but of course also for the patients. Yeah, and factory planning, something that is done in VR to a large extent, that is somehow related to operating room design. Yeah, when we look at the situation until 2014, the availability of VR hardware was very limited. That was hardly affordable. Not only was it expensive to buy, but also it was expensive to maintain it. Yeah, you had to spend a lot of money over and over again. So there were few prototypes, even fewer commercial solutions. The only thing that was already quite successful before 2014 was treatment of psychiatric and neurologic disorders. All of this has changed with the advent of the affordable VR glasses like the Oculus Rift and the HTC Vive that become better and better in terms of field of view, spatial resolution, and other properties that makes the experience really convincing. Yeah, what can medical visualization research contribute? I think we have developed many techniques to show surface and volume data in a high quality with a lot of depth queuing involved. We can come up with smooth solutions that avoid artifacts that are distracting. The cinematic rendering is maybe the state-of-the-art volume rendering system. So all this is available. There are many special techniques for vessel visualization. Yeah, these elongated and branching structure require special treatment. There are good solutions for virtual endoscopy, for visualization of fiber tracts, and not only the static visualization was developed quite well. Also, a lot of effort was spent to come up with good interaction techniques. And there's also a good documented understanding of the needs in surgical planning. Yeah. So my vision is a bit to combine both. Yeah. And this relates to some challenges. Yeah. Christina asked me I should talk about challenges. So I try to do this now. The first challenge is, of course, where is this combination really useful? Not everything that is feasible to do in immersive VR really is justified and makes sense. In VR, there are stricter requirements to latency and frame rate than we would have them in a desktop situation. Yeah, if you move your head in VR and expect that head tracking works and the system is not able to immediately update the visualization, you really get headaches. Yeah, so that should work. Many interaction techniques need to be adapted. System control, as mentioned, is also important. And what I noticed is that most of the applications that I have in mind and are relevant for physicians require cooperation. However, most medical visualization techniques were developed with one single user in mind. Yeah, and one challenge relates also to the question how to perform such research. The strategy that we have in Magdeburg, and perhaps that's not very effective, is we try to learn everything about VR ourselves and to integrate medical visualization with VR ourselves. It would also be possible, of course, to cooperate with VR experts and not trying to do everything ourselves. Yeah. Yeah, some examples of what already works. I looked for this, of course. So there is nice work from Ari Kaufmann's group on virtual endoscopy in VR, and I think that's very convincing. Yeah, to move inside the colon, for example, or inside the bronchial tree, that probably really benefits from VR. There is a lot of work in Thorsten Kuhlen's group, and that is just one example where they try to use immersive VR for neuroscience research. We spent a lot of effort in translating blood flow research in VR, primarily motivated by our colleagues from flow engineering that tell us that an understanding of the interaction between a surface and the flow, if this is complex, is really difficult. So they say that this could be quite important. Yeah, and for us, anatomy education is also an important field. Yeah, just to include some images, this is from Thorsten Kuhlen's group, yeah, where they developed a lot of techniques in order to support basic neuroscience research. This is an example from our blood flow related research. And here are two examples from our anatomy education research. So here, for example, the user moves his hand and the virtual hand is moved appropriately. That gives you really a good understanding of what happens to all these different structures here of the hand. Yeah, so a sense of embodiment that should be achieved here. That was our major goal here. Here are many things, again, completely different. Requirements can be very special. Users should learn about the skull, about the foramina, these holes in the skull, and the structures that go through these foramina. So we came up with a very large model, 100 times larger than it actually is. And you are a very small person here inside, and the teacher supervises you and can help you and guide you. So yeah, that is just one example of this work. Yeah, and for completeness, of course, a list of references that I used to prepare this talk. Thanks a lot for your attention.
Thank you, Bernhard, for the very nice presentation. And our next and last speaker is going to be Eduard Gröller.
Okay, thank you very much to the organizers for setting up this application spotlight. The title of my talk is in Latin for two reasons. The first one is I would like to impress you. And the second one is that in the past, medical doctors were using Latin. It was the language, the lingua franca, and they could communicate with each other. And it was only a small group that were in this business, but they had an understanding and could clearly talk to each other. If you look at the situation nowadays in medical and biomedical visualization, you have an awful lot of different stakeholders, from radiologists, from medical doctors, physicians, bioengineers, public audience, patients, software developers, visualization experts. And the question is, how do they communicate? And might this be an issue in this area? And actually, there's the Austrian philosopher Ludwig Wittgenstein who said, the limits of my language mean the limits of my world. So what you cannot express in your language, it's very difficult to communicate with others. And a medical and biological visualization is a fascinating application area where we have a very high heterogeneity of different experts that should communicate to each other. But let me come, so is visualization, medical visualization using the right language, or is there one language at all? But let me come back to what the organizers requested. They asked for a 10-minute presentation to talk about challenges and how we can tackle those. And they were even so optimistic that we could even include our own ideas. Well, I was not going so far. I had the feeling, why should I have own ideas, and why not asking other people for help? So I was doing an informal ad hoc opinion poll in my network that has emerged over the last 25 years. And the idea was not to always talk about sort of in my own bubble and see what other people challenges. So I took basically the questions of the organizers and added some other questions like what are failure success stories, for example, what are stumbling blocks, and so on. And also asking what are, apart from visualization, what are open challenges? Maybe there are some more pressing challenges and visualization is just a sideshow, for example. And so I even got feedback from several people from the medical domain, physicians, medical doctors, but also visual computing people from applied research centers, then clinical researchers, for example, but also from people from large healthcare companies that are producing software and devices in this area, like from GE, Philips, and Agfa. And so in the following, I will give a list of summary of their feedback. I have a two-level summary, but I will just talk about this upper level. If somebody is interested, I can provide the slides then. So what several in the brackets, I'm giving the number of people that mentioned this topic, but this is not very strict. The first thing is about artificial intelligence, deep learning. Naturally, Anna was talking about that. I'm not going into detail here. It's about the black box, for example. It's about the bias that can be introduced. The second thing is comprehensive visualization. There are so many different modalities. How can you accommodate these modalities? And the issues are concerning confidence, reliability, robustness, for example. And another topic is uncertainty calculation and visualization. How can you determine accuracy and precision in image analysis results in a patient-specific way, for example, when you think of precision medicine? And then the next topic was mentioned very often. It's about intuitive, simple user interfaces. So it should be what we are producing. It should be intuitive. It should be easy to integrate in the workflow of our customers. And it should be similar to what they are used to. And this then to a certain degree restricts our creativity. Visualization, speed, and efficiency. Bernhard was mentioning this in the context of virtual reality, but sometimes people are interested in the combined interaction, visualization, maybe machine learning, and then the systems should be fast enough to have a real-time interaction with rich visualizations, for example. Trust was mentioned also by Anna, but that doesn't only involve artificial intelligence and deep learning. The data is going through so many steps until it ends up as an image. How many errors are introduced there? I mean, what are features, what are artifacts? Many people plainly say, I don't trust visualization. I'm not sure about that. Another topic is standardization. That has been mentioned quite often by the domain experts. And I remember 30 years ago in computer graphics, you had papers on standardization. Nowadays, you don't see it in our area. But DICOM, for example, is already 40 years old. We would need a new data format, new standardization, if you also think of electronic health records. And then clinical application-driven visualization is mentioned. So to counter, I have a solution, what is your problem? The next topic is interdisciplinary and integrative research. So if you look at many of these realistic problems, they involve so many different experts from very many different disciplines, and you cannot only solve it by yourself. It would require the involvement of many different experts, large initiatives. Some of them are around. But if you think of our small research groups, it's very difficult to get this going. Data preparation, data handling, and big data is actually a big issue. People are telling you that the data curation takes actually much more time than the visualization itself, and garbage in, garbage out. So if you make mistakes here, the following visualization is not very useful. And then stop doing the old stuff. I mean, there are techniques out there for simple techniques, for simple modalities, for diagnosis and treatment, but maybe we should go more in newer directions like prediction, prevention in a way, or opening up to new target user groups, patient briefing, for example, or the general public. If you think to convey the current pandemic for people, for example. And then I think this has been mentioned before, VIS and MedVis. It would be great that they are coming together again, more closer. This was mentioned in the VIS conference at the beginning of this week as well. But sometimes they are very important subtopics of life sciences, but they are working on different scales. They're using different languages, and how can we bridge that? And then there were mentioned several stumbling blocks and issues with our reward system. A classical one is between creativity and relevance. I mean, if you do something that is relevant for the clinical personal, it might not be very creative and will be very hard to sell to the visualization community in a way. That is an issue. And sometimes simple is mixed up with trivial. Sometimes really simple solutions are that what clinicians need, but they're considered to be trivial in the VIS community. Okay, so I was also asking for success and failure stories. I will just shortly mention 3 of those, will not show the animations. We had a big success with our blood vessel visualization over years. We had several PhDs, we had several projects and various fundings, and a research prototype of the software has been used in clinical practice. So this was scientifically a big success. Then we had with a company ultrasound project where we included basically computer graphic special effects like translucency, soft shadows, and ultrasound rendering. And this had a big commercial success for our company partner. Initially it was intended for parents, for example, but was very much liked by doctors as well, and they were using it for a diagnosis, which made us a little bit nervous because in graphics you're doing shortcuts, and for diagnosis you need accuracy, precision, for example. Below here we see a SARS-CoV virus image from our spin-off, and here if you look at the dissemination strategy in this area, there has been a tremendous success of visualization in this area. If you look at the New York Times postings and information, with all type of visualizations, not only spatial but also InfoVis, they are using for disseminating information. And at the last VCBM conference, Hans-Christian Hege was giving a keynote talk where he was showing all kinds of visualizations in this area. So in this dissemination domain, this has been a great success. So this is about all for the moment, and I have the feeling that for this field, clara futura in vobis, and so I'm now open for discussion. Thank you.
We would like to switch to live panel, and Noeska is going to give out the questions, and then all can answer.
Sorry, could we do like a view of all the speakers at once? Would that be okay? So for the rest of you, I will be reading questions from the document. So Thomas and Christina, I will give you the word when one of your questions comes up, okay? But I thought of answering the audience questions first.
But we are visible all the time, right?
Yeah. Thanks to all the speakers for these excellent talks. I'm sure there are many questions from the audience listening in on these. So I thought we would start with those, and then if more questions come up, please post them in the Discord. But for the first question we have is from Fatima Rajabijaji. Do you consider publishing in medical visualizations in medical journals, or how do you decide where to publish? So it's a question to all panelists, but let's start with Anna.
Hi. Usually I look at the focus of what the work we do. So I publish sometimes in also medical journals or other journals, but these are mainly because our collaborators are publishing there, and the focus is more in the outcome of what we developed than in the visualization aspects of it. When it's the visualization aspects, I then go more to the technical, I would call kind of journals or conferences. The question is also in our field often whether visualization is also the right community for that, because often we are somewhere in between feature extraction, machine learning and visualization, and sometimes it's difficult to find a good in-between place where the contribution is clear.
Any comments to that, Bernhard?
Yeah, I think about, we primarily publish at the visualization venue. So if possible, I focus things in this direction, but I also have partially the problem that Anna mentioned. So in addition to our VR-based work, we also work with machine learning. And for example, last week we submitted a paper to artificial intelligence in medicine. Yeah, so sometimes that is a better solution. We have the VCBM workshop, which I think is a good venue for a lot of our work. We never published clinical journal papers ourselves, but we try to support our cooperation partners as good as possible so that they are enabled to do this. And I think, yeah, for them, this is the major goal of the cooperation with us. So therefore, we really should support them to do this. And they need numbers primarily, yeah. So they need something they can quantitatively analyze, not just a collection of nice and good looking images.
Yeah, that's also been my personal experience. Edi, any feedback to that?
Well, basically, it's the same as what Anna and Bernhard is saying. When we develop a technique that is strong on the technical side, we try to place it in our community, and we publish with our domain experts in their domain, because they know how what are the requirements and what type of information is needed there. But it's not easy to get publications in our domain going, because in many cases it's the simple techniques that the medical doctors prefer and like and need, and our simple techniques are considered to be trivial. So in some cases we try to get around by it by designing to, in addition to the simple techniques that the doctors like, something that is a little bit more complicated and that might be interesting to them as well, sort of to explore the design space, and then we can place the publication in our field as well. But other people from the applied area, they are sitting between the chairs. I mean, their customers need something that is helpful to them, and then the visualization turns out to be, has to be robust, has to be reliable, and then it's usually simple. And then placing such publications in our field is very difficult for them.
Yeah. Thanks for that. She also notes that one problem in medical data visualization is to have access to the right medical data. And she didn't put a question in there, but I will, if I may. So is there anything we can do as a community to remedy this access to data situation so that we can be more inclusive, in that people without having the right collaborators immediately will also be able to work on medical data visualization problems?
That is difficult, and I think having access to data would only be part of the solution. So what we did, for example, is not about image data, but about epidemiological data, use data from the internet. Yeah, there is more data available than 10 years before. And we developed some machine learning techniques for this, but you need an expert to interpret this. Yeah, you just play around with the data. At the end, you need to have cooperation partners. Just having access to data does not help so much. We use sometimes the OSIRIX database that has, yeah, for example, even multimodal data and so on. So in addition to the data from our cooperation partners, that is a good thing also because some of these images may be even considered as benchmark images. Yeah, but I would always recommend to search for a real cooperation partner. Otherwise, you cannot evaluate your solutions.
I think that was something that a medical doctor, a clinical researcher pointed out, that machine learning is very prominent and popular right now, but it's not clear if it really will fulfill all the promises. And there, it's a tool, it's not a solution. And you need the data, but the database itself, as Bernhard says, is not enough. You need also somebody that knows how to handle these data and how to interpret that. So in that sense, the expert is not out of the loop.
So I agree, and the data is actually primarily has a lot of ethical issues with it that also have to be solved. So it's not easy to do that, and the owners of the data is not us. So we can try to convince other people to make the data available and public. And actually, there are multiple initiatives in this direction in the machine learning community and in pattern recognition, also in the clinical community, because they see the need of sharing, but there are a lot of difficulties in doing that due to also the ethical constraints that are attached to this kind of data.
And then you have the issue if the data is not general enough that you get a bias in your techniques.
Yeah, of course.
You are training your data on a specific subgroup from one continent, and other people or groups, or age groups, or ethnicities are underrepresented, and then you are applying these techniques suddenly to a group where it does not fit.
Yes.
When I started with medical visualization, most research was done with the visible human data set. Yeah, that's an almost perfect data set. And people thought, well, that is what you can achieve with clinical data. No, you cannot, only with this very special data set. Yeah, so that was even misleading, this type of research.
Yes.
Good point. Yeah. I also have a question from Nigel John. It's actually more of a comment on our introduction. So he wrote, our graph is a publications in TVCG only, so this downward trend. And he asks, is this trend across all major journals also downward? So we personally don't have the data on that, but I'm wondering what you're thinking. Is like traditional medical visualization, if we can call it that, is that on the downward trend, or is it still very much a hot topic, let's say?
There are many topics within medical visualization that are solved quite well meanwhile. I would agree with this. For example, I like virtual endoscopy a lot, and whenever I give a lecture on virtual endoscopy, I update my slides. But in the last years, I find nothing to update my slides because nothing has been done. Yeah. With medical volume rendering in general, I think also there is not so much to be done. To find good transfer functions for MRI data, that is still a challenge. Yeah, people only use CT data for good reasons. So I think some challenges remain, but some are also solved quite well.
I do think that often sometimes visualization is also generated in other communities apart from us. If you look at the flow visualization or, for example, diffusion weighted imaging and so, a lot of things were reinvented also in other communities. So they reinvented the streamlines and things like this, or visualizations that were known to us. And there are visualizations in the medical field that also are published in other contributions that are mainly visualization, and they are not in our field.
Maybe if I think of what still is not researched adequately, if you want to explore at least a small cohort of people, and you need comparative visualizations that give you an overview about similarities and differences in the morphology, in pathologies, but also in related clinical parameters. I think that is a challenge that remains.
All right.
Yeah.
Thanks. So we have a next question from Renata Raidu. She asks Anna, but also the others, do you think that except for the great success of the visualization machine learning marriage and the great challenges that it poses research-wise, we're also threatened by a loss of resources to fields such as machine learning? I mean, machine learning, she means, not me, maybe also me. Machine learning has attracted rightfully so much attention in the last few years that a lot of the monetary and human resources have been moved to this field. And maybe we're taking away from VIS. Do you have any response to this?
Well, my experience is indeed that if you talk to students, a big amount of them want to do things on the AI direction, but I'm not sure, or the machine learning direction. But I'm not sure how much of that has been taken from the visualization. I guess there is a lot of attention for AI, but I think people who really like the more graphical side and the visualization side still are attracted to do something with the field. And I think this was before and it's still now. Mm. But I agree that a lot of people now, there is this big hype or this big thing on machine learning and AI. And you see that the students have a tendency to go in that direction.
Funding-wise, I would say at least the VR field is also quite attractive. Yeah, so we had not too much problem to get funding for our VR-based research.
I mean, there are always hot topics, and like you have machine learning, AI, you have big data, Internet of Things, and they are taking away the students. And I think that what Renata points out, it's really important to get good students, but then the field has to be vibrant, and it has to bring them job opportunities. And the field can only survive if the brightest students are joining this area, and they can make a living out of it. And I think there are various directions. Healthcare, as long as the humans are around on this planet, they will care for healthcare. I think there will be many more directions in therapy, ambient assisted living, where visual means will be an interface. Maybe it will go way beyond of a simple isosurface rendering, but I think there are many interesting directions. We just have to motivate the students, and sometimes it's also a little bit piggybacking. You do a little bit machine learning, and then when you have caught the students, the visualization part is then getting a little bit large in the project, for example. But I think we have exciting topics still.
Yeah. Maybe we should contribute to the development of COVID-19 vaccines, then we are on business.
That would be wonderful. The next comment is from Nigel John, and it's directed to Bernhard Preim. We need a good definition of VR. Currently, the focus is mainly on vision, less on audio, and even less on touch.
That's right.
We need all senses for a fully immersive experience. And also, he states that he doesn't agree with the fact that VR is now in a mature state, and he would still rather consider it an emerging technology. How do you respond to this?
Nigel is the better expert for VR than I am. So if he says it is not in a mature state, then he is right. My impression was just I could read a lot about all these topics that I mentioned about different strategies and solutions. And for me, it gave the impression of something where I can really rely on, not something very fragile in the first stages. The IEEE VR conference started in 1990, and that's a very strong and established conference. So that led to my impression that this is in a good state. I definitely agree with what Nigel said about touch and audio. It's just that I'm not very experienced with this. But if we aim at surgeons, of course, touching, that is something that is so important for them that I'm just convinced that integrating this is really important. And then you have conflicting cues from what you see and what you touch. So that makes things, of course, a bit more difficult, but it's definitely worthwhile, right?
Yes, thanks for that. Next up, we have another question on VR from Anakin. In VR for medical imaging, I assume scaling, zoom in and out of body anatomy would be an important part. I've not seen much research on if there's any correlation between scaling in VR and sickness. Do you think that if a user using VR and constantly zooming in and out to look at anatomy, would this increase motion sickness? Or sorry, VR sickness?
Yeah, sickness. This could be. I have seen more research on the locomotion techniques. So teleportation is often used primarily in order to avoid VR sickness. If people have to follow curved lines with high speed, unnatural viewing directions. So there are a number of things that are investigated quite well, in addition to latency problems and other performance problems, but I'm not aware of research related to scaling.
Okay, very interesting. Next up, we have a question from Juliana Müller. It's directed to Anna, but also to everyone. When we want to use machine learning to get to use in clinical environments, we also have to consider the quality of the medical data and thus have to validate the model later on. For example, I'm currently working with data recorded within clinical routine, having 76% of missing values on average. As you can imagine, this data is not very well suited for machine learning, but it still offers valuable insights. So maybe a future direction would be the domain expert validation of learning models.
I'm not sure I can follow exactly the question. The question is that you have data in which you have missing values, right? So, and you are trying to understand the model?
Yeah, she's asking if it would be interesting for the domain expert to validate the model, the learning model, somehow.
Yeah, so I think validating the learning model is an important part of where visualization could help on. And having missing values, I think it's also something that is under developed or paid attention with in the visualization community, but also in general. I think often these problems are solved by filling this missing value somehow through some procedure and then running further processes for getting what they did to fill these values. And actually these values can have a big effect in your final results. And you never go, well, I don't know whether you never go back. I don't have enough experience on that. But from my experience, you don't go back to see whether your pre-processing was actually messing your data. With a 76% of missing data, I am not sure. I think visualization can help you getting insight there, maybe better than any machine learning or automatized method, I would say.
I think data curation has been considered to be a very, very big problem in visual analytics all the time. And also now in the medical domain. Some people have the feeling they don't have control on the data. It would be much more helpful that they can influence the data generation, which sometimes they cannot. And then they have to do something with the data and how these errors or these imputation that are done are communicated is actually an important step that has to be done. And that finally at the end, that it decides also that the trustworthiness of your results. And this with the missing data, for some conditions, you don't have a lot of data. So maybe there's a rare disease, or maybe you have difficult scanning conditions, ultrasound, if you have people that, obese people, for example, where the scanning makes problems. So you have all kind of biases in the data that you have to be very careful. And sometimes you can influence that and sometimes not. And that's a big issue.
I can only add one thing. Our research on missing values was really driven by the application scientists. They asked us, could you help us in better conveying which types of missingness we have, which dependencies there might be between different missing values. So that was not our idea to do this, but indeed the idea of the epidemiologists.
I think it's a real problem.
Yes. The next comment is from Matthew Nipu. In terms of machine learning or AI, we know that no AI or machine learning model will be able to predict 100% correctly. Hence, how can we, the clinicians or doctors, be able to take decisions on this? Because in medical environment, you're dealing with real people and their lives. If we're to use these methods, what sort of precautions should we take?
So I think there is no test that you can make that is 100% correct. So aiming at 100% correctness, I think, is a bit fictional, but you have to be aware of what you are doing to have some understanding of what you are doing. And I think this is what it's the problem in general, that you don't have an understanding on when things can go wrong or how you should interpret the decisions that are being taken. So I think aiming at 100%, of course, is completely unrealistic, but understanding in which situations things can fail is what is important to understand.
I may add that I'm aware of some research of Cuneo Doi, already 10, 15 years old. We tried to classify tumors, whether they are malignant or benign, and their systems gave a percentage of reliability. So this tumor is 75% malignant. And it turned out that in combination with the doctor's assessment, the overall assessment, so to say the joint assessment of the system and the physician was significantly better. Not 100%, Anna is perfectly right, but better. And I think then it is worth to do this.
Yeah, so actually indicating the uncertainty of the system. Yeah. So that's also an important aspect, right? So how certain is the system about the decision is taken is also an important aspect to be considered.
I mean, you have in any procedure and classification, you have these sensitivity, specificity, and other quality measures, and that's you can have for the automatic techniques as well. And if you know what how much the error can be and the error modes, then this is a big step. Like, for example, if you think of MR data, the medical doctor doesn't need to know all the technical details of the scanning procedure. He needs to know what type of errors and features might show up. And if you have an automatic machine learning technique that is taking away a lot of routine, simple cases, this is also helpful, because then the experts are really concentrating on the complicated one.
Yeah.
Right. Nice. Next question is from Sanjana. I guess it's directed to Bernhard mainly. How much enthusiasm do doctors or clinicians show to wear VR devices for a long time?
Yeah, if I think of our cooperation partners, we work with a clinic in Mainz. These are surgeons, and we work with them together since 3 or 4 years. They are really enthusiastic about it. So they have the VR equipment themselves, so we can easily send something to them, and they make their studies even themselves. So that is a clinic where this really works very well. Also, the anatomists in Magdeburg are quite enthusiastic about it. And we work together with partners in Leipzig at the university hospital there. They really make currently, even under COVID conditions, a study where they treat stroke patients with a software that we have developed, that people can train to cross a street safely in VR, yeah, with different difficulties. The cars are closer or not so close, faster and not so fast, 1 lane or 2 lanes, so we can parameterize this a lot. And that is used there since half a year in a study for patients that have a spatial neglect after a stroke. Yeah. So at least we find for all the topics we are interested in enthusiastic partners over a long time. What I would not expect is that VR will be used for routine diagnosis from radiologists. Yeah, I don't think that this will happen. But for surgical training, for example, I can imagine this quite well.
Very nice. A follow-up question by Helwig Hauser. I very often think that one of the great potentials in visualization is that we can generate views that complement real-world views or near real-world views. Don't we make it hard or harder to do so when assuming a VR setup? And he's thinking about combining spatial, non-spatial views, bridging scales, embracing spatial reformations, etc.
Helwig is right. There are situations where VR is not an advantage, where projection-based techniques and other things that nicely summarize data are more appropriate. But in some situations, really this immersion, this in-depth understanding of a complex anatomy, complex spatial relations helps a lot. The key example for me was when I saw for the first time a model of the human brain in VR with all these folds, yeah, that becomes so obvious and clear to you if you see this in VR. There it really helps.
Actually, we had from the biological domain a guest professor in our group, Art Olsen, and he's in his 70s, and he was always stressing the importance of 3D representation. Like he was saying that the double helix was sort of deciphered by people making a really physical model and then understanding that. And then his people were providing him with a VR setup so that he could look at some proteins. And he was really literally spending 5 or 6 hours in this virtual environment. He was totally immersed and was looking at these protein structures. It was really fascinating. I think he's not an average person, and you cannot expect that from the other people. But also, for example, for educating people, there is this term of physicalization or 3D printing, where it might be possible that you get artifacts that you can touch and that you can interact with it. Maybe not so easily as in VR, but for certain things to understand, having a view on the 3D situation is apparently very, very helpful.
Very nice. The next question is to all panelists from Laura Garrison. She asks, how important or interesting do you think it is to consider how we can integrate techniques or approaches from the art world, for example, medical visualization, illustration, into our medical visualization techniques?
Yeah, maybe I start. I like this work a lot, and I find it is quite important. Meister's group and my group have dealt with illustrative visualization, but I think my group never has collaborated with an artist. So just looking at textbook images from artists and trying to reverse engineer how they did this and to come up with something similar is not so promising as working together really with medical illustrators. I think that is really something that has potential and is certainly also a future challenge.
Yeah, so I did some work on this in the past, and we did talk to illustrative medical illustrators. And actually the medical illustrators, they generate also 3D images themselves to be able to generate their own illustrations. So I think there is definitely a lot to be done there. And I think there is a lot to learn from the artistic aspects where they have all these techniques to make things clear, right? So to be able to communicate what is important in a clear way. And for a lot of aspects, the problem we have is that the images get very cluttered. And I think this kind of techniques have been also around for a while, these illustrative techniques. And I think they are still very useful and something to always think about to incorporate in the visualizations when you are dealing with complex and cluttered kind of information.
I can only agree. Currently, even Viola is working with together with illustrators, and I think in the dissemination and in the patient briefing, this is very promising because the aesthetics are clearly increasing the engagement. and producing very nice results.
Okay. Then I have a next question from Jörg Meyer. He says, we've seen how difficult it is to translate visible human-style curated methods to real patients. This is also known as personalized medicine. So a question to the panel. In your mind, what is currently missing?
Missing with respect to what?
What?
To translate methods developed on data sets like visible human style to real patient data, how I interpret it at least.
I think the processes to get visualizations like you have gotten in the visible human kind of data are still very tedious and manual, right? So if I'm correct, a lot of the visualizations were done also sometimes with manual segmentations and things like this. And in a clinical setting, time is crucial. So you don't have enormous time for every person generating the visualizations you could do with this kind of methods. Although for some aspects we are getting there to get a lot of automatization or so. But also I'm not sure to what extent all is necessary. So I think it depends on what the people needs is what you're looking at. But yeah, this idea that you have a full report of all that's going on in your body after you get a scan also, I think there is a lot of things still need to be done to get there.
I agree with Anna that solutions, visualization techniques that require that many objects are carefully segmented have only limited applications. In radiation treatment planning, that is really done. But in surgery planning, for example, it's typically only done in a research project as long as the research project is funded.
Yeah. Next, I'd also like to share some questions from our own organization. So I give the word to Thomas.
Sorry, it took me a second to unmute. The question I had, it was triggered by Anna's presentation. You mentioned evaluation as being one of the issues. And in the medical domain, there's a lot of gold standards for all sorts of problems. And so the question is, would it make sense to develop gold standards for visualization as well? Of course, there's a difficulty that there's so many application areas that it might be difficult. But what's your take? And same thing goes for the other panel members.
Yeah, so I think this could be useful to do for, but it's hard to do because, as you say, it's very application oriented, right? So gold standards could mean that you have a specific kind of visualization and people evaluate them in a specific standard way. And this is very much application dependent. And I think sometimes in the tests we do or the user kind of evaluations, we try to build a small kind of this gold standards, at least to the extent I understand it. But to make it generic in a generic way, that's a bit difficult to do. Yeah, I think it's a good thought to think about how to do that in a general way, actually. But
I think sometimes we are doing something like this, but we avoid the term gold standard in our field, I think. Yeah. So for example, we dealt with methods, how to map some information or how to provide better depth perception in vessel visualizations. And I consider work from Timo Ropinski's group with pseudo-chroma depth color shading. That is what I consider as the gold standard, but we haven't called it gold standard in the paper. We said that is the base method or the reference method, but actually it has this purpose.
Thomas, do you have more questions?
Yeah, I wasn't sure if Edi was going to chime in or not.
I was just thinking maybe the radiologists, they have their gold standards and their baselines, and then the question is, like in angiography, digital subtraction angiography and other depictions, and then we are mimicking those. But I think it would be also great to start even earlier with having a normalized data model in a sense. What does the normal patient look like with including variation in that sense? But I think with this is a fleeting target. I mean, the patient is not changing so much, but all the scanning technologies are constantly developing, and so it's very difficult to get standardized data that is valid for a longer period of time.
That is true, Meister. When you talked about standardization, I thought primarily about standardization in the image acquisition process.
Yes.
Yeah? So, for example, blood flow data is acquired very differently. Perfusion data is acquired very differently. And I've seen radiologists talking about that the differences in the acquisition parameters are stronger than the differences between healthy and normal patients. So it depends on the scanner whether you will be assessed as having a malignant or benign tumor with perfusion data, for example. That is really a problem. So although there is the DICOM standard, that does not prevent that the sequences and protocols in MR, for example, are quite vendor specific actually.
Yes. This also applies, for example, for ultrasound, where it also depends on the type of patient and on the anatomy, how the data quality is then given.
Yeah, interesting. Thank you. My second question revolves around trust, but from a different perspective, because we talked about obtaining data earlier, and so for all the newer researchers that are entering this field, is there any recommendation in terms of how you establish trust with your collaborator? Because I mean, it takes quite a bit. It's medical data. It's maybe sensitive in various different ways, and so people from the application domain have to some extent trust you with their data, and sometimes even they have spent a lot of time generating the data, so it may take a little bit. Is there any recommendations you could make?
Well, in the past, the people were coming with their data and they trusted their data, but they didn't trust you. Because they had full control of the data generation process and they had experiences with that. And then you slowly had to gain their trust and their confidence with your qualitative visualization techniques, for example. I think in the future, there will be a visualization in the wild, which means there will be so many different data sources out there where you don't have control because they have been generated somewhere, maybe with a slightly different purpose, and not taking these data sometimes into account, then you might miss out. So you have to take this greater uncertainty into account in a way, and maybe you have to do some consensus type of processing. I think it will get more difficult in the future because they will not trust only your algorithms and visualizations, but they will also not trust the data that you are taking from obscure sources, maybe.
I think one thing that is important is the physicians really must have the impression that you take it seriously, yeah? That you don't just want to get access to some data and then run away and they never will see you, yeah? That is what they are really afraid of. It must be clear that you take this very seriously. Also, medicine is very hierarchic. So if a PhD student alone goes to a physician without clear support from his supervisor, the physician probably would not take this very seriously. That is another important thing.
Yeah, and sometimes it's not just a question of trust, it's a question of following all kind of ethical processes, again, at least from my experience, right? So it's not a question that they don't want to share it with you, it's just that through the way the whole thing is developed, you have to sign some documents and get some accordance, and sometimes you can just use the data at the location where it is produced because it's not allowed to leave the hospital. So then you can go there, you can work with mock data and then go there and use it there. And in my experience, you can get all these processes gone when it's clear for them that they are going to get something out of what you are doing. right? So the project or the problem you have to be dealing with has to be clearly interesting also for them. I mean, it's not a question, okay, I get data, I will do some nice visualizations that I like to do, and maybe you will see me, my results sometime, right? Yeah. So the projects are something that you build together, and then it's part of the deal of building the project together that you have to have access to the data. But I must say that we also have our fights with that, right? Mm-hmm. I try to not start a project without having the data. Let's put it this way.
Ideally, you come to the point that you really have a software that the physicians can regularly use at their place to do their own research. If you achieve this point, then the cooperation really has a very stable state.
And this involves a lot of engineering still, because that's and this is a typical issue. Part of the effort that you have, a sizable part of the effort goes into helping them how to handle their data, how to store their data, access that, and do all kinds of software maintenance that is not sellable in any way in the VIS community. I think it's unfortunate we have technical papers, we have application paper. It would be really great to have applied paper, in a sense that you are describing an effort that led to that your prototype is used for a longer period, maybe a year, in a clinical setting, and to describe the experiences that you have out of that. So we are really, our reward system is not taking that in any way into account. I mean, we are doing, if you're lucky, you get your application paper through, but the sustained effort that something is used really for 50 patients, 100 patients, this makes a big difference instead of using it for 5 patients or 10 patients for your application study.
But if you do so, you may get the Eurographics Medical Prize, because there this is really taken into account.
The good incentive.
Yes.
I hand over to Christina for maybe a final question, because we're nearly running out of time.
Well, I think that actually perfectly fits to what we discussed before. I was actually wondering, is there something that we can say that medical application papers are actually not ready to be published as full papers at VIS? Because what I saw, for example, this year we had the best paper in short papers was a medical application paper. One of the honorable mention papers was a medical application paper. But if we look at the list on published full papers, there are nearly none medical application papers. So and if I work with people in medicine, I give them a new visualization, and maybe it's not the coolest thing ever in terms of visualization, but I help them. And how can we make sure that this is going to be rewarded properly? Because I mean, no one can make a PhD out of short papers.
Yeah, so I think the community is making an effort in the sense of starting accepting application papers also. But of course, it has its requirements still, that there is a certain level of something to learn for the community, right? And that's a bit where the things start to get a bit fuzzy, because it's what Eddie also said. If you might make something very useful for the application domain, but if the visualization community cannot learn anything from this, that might be a paper that is more interesting for the medical community to know that this great software is there and that they can use it for solving their problem. That maybe is for the visualization community. But on the other hand, I think there are chances to it's a balance that has to be met. And I don't have a clear answer why there are few application medical visualization papers, full papers this year at VIS, let's say, or in the last years. Maybe at some point also some fields get a bit saturated on the amount of techniques that have been developed, and then they need a bit more time to find new challenges or so, I don't know. But yeah, I see a bit this trade-off between engineering and really giving some value that also the community has can learn something from it. I look at it always this way, right? So when you publish a paper, then the community should learn something from it, not just the person who is interested in this very specific application that you have built.
Yeah.
And that's a bit difficult to find a good balance there, I think. But it's not just with medical. I think this is in any very applied kind of work. Not sure whether others have something to say.
Bernhard?
Yeah, maybe if it's really very application oriented and does not have something general for the VIS community, I would submit it to the Journal of Computer Assisted Radiology and Surgery, for example, yeah, where this maybe is appreciated more. But even there, people, of course, review quite seriously, and there must be a demonstrated benefit for the application. That is what they really pay attention to.
Eduard?
Difficult. I think the academic reward system in such interdisciplinary integrative areas is very difficult. You know, you're sitting between all different chairs, and whatever you do in one field is trivial, and what great things you do in the other field is not understood. So I see that at PhD defenses sometimes that they say, oh, this is just engineering. You should go to the other area and defend your thesis there. But I think one has to be persistent. One has to point out that if the impact of your work is clinical adoption or bringing your work closer to clinical adoption, that can be maybe helpful. But on the other hand, it's a mature discipline. I mean, we have been working on this for 25 years, and only small parts of the techniques have made it into the clinical work, like in many other application areas as well. I think this is only very, very natural that we have to generate ideas, and few of those will fly finally in the clinical domain. I think it's a fascinating area. I think the combination with biomedical tasks across many scales. So there are areas where I think it's easier possible to get a VIS paper. Not so easy in volume rendering, not so easy in isosurface rendering. But if you have ensembles and if you have massive multimodal ensembles, if you have interaction across scales from the phenomena that are described on several, I think that that can bring you VIS papers.
One thing that maybe the community could be more linked towards is to also accept papers that are not pure the visualization contribution, but also the other aspects like the image processing and the feature extraction. Sometimes this is an issue. And I shut up because I know we have to finish.
Unfortunately, that's right. We have to close the session. But before we do, I would like to thank our panelists very much for their inspiring presentations and also for the lively discussions. In addition, I would like to thank the audience for their questions. And speaking of questions, there are more of them in the Discord. So if our panelists would have the time, it would be really excellent if you can join the channel and discuss further about these important challenges. But for now, I'm afraid we have to close this session. So thank you all very much for your attendance and hope to see you around at VIS.
Thank you. Thank you all.
Thank you.
Bye-bye.
Thank you for organizing.
Blockchain has gained more attention and its applications are emerging. We collect 76 blockchain visualization tools and systematically classify them into 5 aspects: target blockchain, blockchain data, target audience, task domain, and visualization type. In the end, we look at open challenge in blockchain visualization.
Nowadays, data is often distributed and owned by different participants. There is an emerging need to provide a joint visualization, such as a TS&E projection, to serve as the full picture in data analysis. If the participants are privacy sensitive, how can we build a joint projection without data leakage? Conventional embedding algorithms, such as the TS&E, are designed for single-site computation and require data centralization. Privacy leakage may happen in 3 stages in the visualization pipeline.
We present a framework for the visual exploration of spine simulation data. We show the force distribution on spinal discs, enable assessments of imbalances, and reveal impact vectors that were not accessible before. This is a novel direction in medical visualization, and we hope that it might bridge the gap between biomechanical research and clinical application.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau, answer questions at the speed of thought.
We propose data-driven space filling curves. Our new method generates linearizations that better preserve coherency than existing techniques. Our method supports 3D datasets and even multi-scale data on a quad tree or an octree. Many visualizations benefit from our method. For example, visualization of multivariate particles and visualization.
To interactively explore and visually analyze large multivariate data. For example, this cosmological simulation that is clustered into dark matter halos. We create a probabilistic data model in each cluster. We present a complete visual analysis system based on this data representation, which is especially well suited for the density-based visualizations shown here.
Traditional flow visualization methods, such as the line integral convolution, convey information about the underlying flow structure. However, the influence of regions in the flow on each other is not visualized. In my talk, I will present a new dense flow visualization technique, creating a multi-level hierarchy that provides insight into the region's connectivity using a probabilistic model. For more specific details, come to my talk.
Many techniques can be used to render and visually explore large 3D line sets with transparency. However, all these techniques differ in several aspects such as runtime performance, memory consumption, and image quality. In this work, we provide an extensive comparison study to discuss the advantages and drawbacks of transparency rendering techniques for large line datasets.
We present an interface to visually analyze and steer zero-shot learning models. Our interface is designed to diagnose attribute mispredictions to convey potential failure modes in zero-shot learning. Using our interface, the user can select multiple categories for analysis. We allow the user to steer the model by changing the weights of potentially problematic attributes based on their analysis.
Firstly, we extract contours of virions and distribution of spike proteins. From a newly estimated contour, a 3D mesh with evaluated triangles is obtained. In the last step, rules describing relations between protein instances are defined by the user. The resulting model is created by application of all rules on the generated 3D mesh.
Hi everyone, I hope you're doing well. I'm Heikyu Park from Georgia Tech. I'm very excited to present Bluff, a visualization tool to interactively decipher adversarial attacks on deep neural networks. Deep learning is now commonly used in many domains. For example, in the medical field, deep learning models can estimate the treatment effects on patients. On the road, we can see self-driving cars using computer vision technologies. However, deep learning models are vulnerable to adversarial attacks. An adversarial attack applies carefully crafted perturbations on data inputs. and fools a model into making incorrect predictions. Adversarial attacks jeopardize many deep learning-based technologies, especially in security and safety-critical applications, such as data-driven healthcare and self-driving cars. Due to the threats of the adversarial attacks, people cannot confidently use deep learning models. To overcome the vulnerability of deep learning models, we need to understand how the adversarial attacks permeate the model's internals. Also, for a better understanding about adversarial attacks, it would be worthwhile to examine if and how an attack strength changes how the model produces incorrect predictions. For example, it would be useful to know if a stronger attack exploits the same neurons as a weaker attack does, or if those sets are completely different. We present BLUF, an interactive visualization tool for discovering and interpreting how adversarial attacks mislead DNN into making incorrect predictions. Our main idea is to visualize activation pathways within a DNN traversed by the signals of input data. For given input data, an activation pathways consist of neurons that are highly activated and the most influential paths. Activation pathways represent what features are detected and how those features are related to contribute to the final prediction. To understand how the attacks manipulate the neurons and the paths inside the models, BLUF visualizes the activation pathways of both benign inputs and attacked inputs. That is, BLUF finds and visualizes the most activated pathways given benign and attacked input data. BLUF also visualizes the most inhibited paths by the attack to uncover where the attack is blocking the signals to the benign path. Also, BLUF visualizes the most excited paths by the attack